I like to use these little battery packs when developing circuits or working with the Arduino because it's a great way to provide 5 volts and it's super convenient. They're very light, they're rechargeable, they just take an 18650 cell in them. But they also have some other interesting features, like they do have a short circuit detection and it will cut out if you ever cross a wire, which can be very helpful so you don't fry something out. I also like to use these little voltmeters, amp meters that plug into them so I can see what's going on. Now, there's one downside to them, and that is, as you can see, the current draw is often too low for it to stay on, and so it will just do an auto shut off. And the worst part is that it varies significantly from one of these battery packs to the other. This one, for example, will go about 15 to 20 seconds before cutting out. This one will do a minute or two, and I've got some others that are even shorter and some that are even longer. But inevitably, they cut out. So today, what I'm going to do is I'm going to show you a quick little hack that I did to prevent this from happening. Let's talk about these little battery packs for a second. They come in a lot of different shapes and styles. These ones have a single 18650 in them. This one I think has 3. They all have the same features. They've got a 5-volt boost circuit. They have an internal charge circuit. They do that voltage cutout if they detect no current. And they also have a short circuit protection, which will just cut out and will stay cut out until you unplug and replug the device. They're super handy and they're also really inexpensive. These ones are about $2. These white ones here are about $1.10, $1.20, and this was a kit for about $2 to $3. And it's a really nice little battery pack. It's a great way to power your projects. But as I mentioned, they all suffer from the same problem, and that is if they don't detect any current, they'll go ahead and just power off, and that will it's just not convenient for running an Arduino project. But as you can see, this one here has been running, and the reason it's been running with nothing plugged into it is what we're going to talk about here today. So I'm going to show you how we can mod this little plug, this little adapter here, in order to keep them running as long as you want. All right, so what is this? Well, this goes by a lot of different names. If you search for USB charge doctor, you'll see a lot of different variations. Now, I like these because they show both the current draw as well as the voltage, and they're just really inexpensive. These are about $2 to $3 a piece. You can get some that have more features that cost a little bit more, and you can get some that just show the voltage and kind of cycle through the voltage and the current for about $1. And it's really helpful to have a bunch of these on hand. They also have 2 outputs, so it will split one of these into being able to support 2 devices. And this is what we're going to use to modify this so that it stays on as long as you want it to stay on. So the very first thing you need to do is get this apart. Now, it turns out this one, and your model may be a little bit different, is literally just clipped on. So this one didn't have any glue or anything. If you just take a screwdriver and slowly kind of work on the front clip and then the back clip, you'll be able to pop this off. Now, one of the things that you'll notice is that this has a tremendous amount of room on the bottom here. And the reason is it's got some little standoffs in there. So this is going to provide plenty of room for us to put some additional resistors on the bottom here and be able to trigger this to stay on all the time. One other thing you're going to want to do, and I don't know why they do this, but they've got these little pieces of plastic shielding over them. First thing you're going to want to do is take those off because they're going to affect how bright this LED is. So go ahead and take those off since we're already in here, and this will now show up much brighter through the cover on it. So let's go ahead and talk a little bit about what we're going to do with that circuit. So what we're going to do is we're going to solder a resistor over the positive and the ground of this little charge doctor. And what that's going to do is it's going to trick the battery pack into thinking that there's a load there, even though we just have this plugged in and we don't necessarily need anything else plugged in. But as long as these resistors continue to draw a little tiny bit of current, it's going to think that there's a load on it and it's going to stay on and not going to trigger the auto off. Now, I've tested this on every single battery pack that I have, and it actually works on all of them. Now, that may mean that there's some out there that it doesn't work on and it's still not enough current draw, but if that's the case, you can adjust your resistor value accordingly. So let's talk about what resistors I picked and why I picked them. So I tested some different resistance values and I found that 100 ohms actually worked best for all of the power banks that I had. This will keep them all on and running so long as this little charge doctor is plugged in. Now, because this is just a resistor over a load, we need to be a little bit concerned about the heat dissipation because it's also going to be inside of this little case. So let's go ahead and just run the math real quick and make sure that we're well within the range of these resistors and we're not producing too much heat. So using Ohm's law, we've got 5 volts and we've got a 100 ohm load. So if we do 5 over 100, that's 50 milliamps dissipation, which isn't very large at all. But let's go ahead and calculate out the power. So if we do 5 volts times 50 milliamps, we get 250 milliwatts or 1/4 watt. Now these are a 1/4 watt resistors. So this is still within kind of range. But what I wanted to do just be so that they didn't get too hot. And again, they're going to be inside of this enclosure. So I wouldn't want them to get too warm and there's just simply no airflow. So what I'm going to do is I'm going to actually solder two 200 ohms together here. And these are going to be in parallel as part of this circuit. Now, right now I just have them tacked on there so I could test it. As you can see, they're kind of just flapping in the wind there. But what I'm going to do is I'm going to trim these down and I'm going to kind of twist them together. And then I'm going to solder them in, and then I'll put a little bit of Kapton tape on there to prevent them from shorting out on anything. But I did test this with all of the different battery banks that I have, and that combination actually worked extremely well. I soldered those 2 resistors in parallel, and again, I've got 200 ohm resistors, which is going to give me 100 ohms. And you're going to want to use your multimeter and just check to make sure. In my case, this is the 5 volts, and then this is just shielded to ground. So what I did was I just added a little bit more solder to the existing solder joint. This is probably going to be lead-free solder, and it's not going to flow very well. So just flow in a little bit of fresh lead solder, and then it'll take that solder much easier. Make sure you don't short these pins out because they're very, very close together. And then I just twisted these 2 resistors together, and I went ahead and looped them around, and then I soldered the other side. So it's not a very difficult job to do. If you're familiar with soldering and you're used to soldering small things like this, you won't have any trouble at all. So now that I've got that on, I'm going to go ahead and put a little bit of Kapton tape on there because I don't want it to short out with the pins on the board. And I also don't want these 2 leads to touch together because if they do, we're going to create a dead short across the 5 volts in ground, and that's going to trigger the overcurrent detection. So I'm going to go ahead and put a little piece of Kapton tape on there and we'll be all set. All right, there's the final version. I went ahead and put a couple pieces of Kapton tape on that so that it's protected. There's one underneath it so it's not shorting anything out on the board as well. Now, I did test this out. I went ahead and ran this in one of these battery packs for about 20 minutes on my workbench just to make sure that it didn't heat up. I kept checking on it periodically, and it does get warm, but it's nowhere near anything to be concerned about. It's well within the ratings of the resistors as we checked, and also just being inside that case, it's not going to cause any trouble. And because that case has a lot of room on the bottom, we're not really going to have to modify that case at all. This is going to pop right back in. So let's go ahead and pop that back in. Well, there you go. It's a pretty quick hack, but it's really invaluable if you're using a lot of these battery little banks, which I find very helpful for running projects. And they just, having them cut out all the time is just such a nuisance. And it'll work no matter what type of project, if it's an ESP8266 or even some type of an Arduino, or, I do a lot of little things like this is a little 555 timer, and they just don't draw enough current to stay on. The last thing that I'm going to do is on mine, I'm going to put a little piece of yellow tape on the back just to indicate that this one has been modified. Now, technically it doesn't really matter because we didn't change anything in the circuitry. It works exactly as it did before. It's just going to keep the display on now. So that's all I got for you. I hope you enjoyed it. If so, let me know in the comments, or go ahead and let me know if you build it. I'd love to kind of see what your variations are as well.